and Namaste. After the completion of this partial differentiation in detail, we are going ahead with the applications of that. Now today, in this particular session, we are going ahead with the application of maxima and minima of a function. We are divided this particular session in different parts, and today's part is about the introduction and few of the questions based on maxima and minima of the function. Now, what is mean by the maximum value? A function f of x comma y is said to have a maximum value at x is equals to a comma y is equals to b if there exists a small neighborhood a comma b such that f of a comma b is greater than f of a plus h comma b plus h. This is as per the definition of pure mathematics of the maximum value. Similarly, minimum value has been defined under the same condition with the minimum value of this x is equals to a, y equals to b. Where is the difference? Difference is here in this sign. It's greater than and it is less than. So again we are defining the neighborhood of the point a comma b to get the minimum value of this particular function f of x comma y. Now what exactly the maximum and minimum value? So the saddle point or a minimax, it's a point where function is neither maximum nor minimum. But suppose what exactly the maximum of what exactly the minimum point? So by using its particular figure, if you'll observe here, maximum value of f of x comma y at a comma b is given by something like this. So this particular point, that means what the point at which the particular value or this particular function have the maximum value. Similarly, the function where it has a minimum value, it's known as the minimum of this particular function. So maximum and minimum values of a function are also known as extreme or extremum values of the points. Now saddle point or mini max, it's a point where the function is neither maximum nor minimum. That is what we have taken it into the consideration. So this is all about the introduction of the what exactly the maximum, what exactly the minimum value. Purposely I have given these figures in front of you so that you can understand. If there is a bowl and this particular type of plane is lying on above that means what the point is to the extremum or to the upper side, then is maximum, and if it is to the below side of this particular curve, then it's known as the minimum point. Now what is the working rule to find out the extreme values? So we have taken it as a bullets, like differentiate function f of x comma y and find out dou f upon dou x, dou f upon dou y, dou square f upon dou x square, comma dou square f upon dou x dou y, and dou square f upon dou y square. So these are the points 1, 2, 3, 4, 5 different differentiations we have to find it out from this. And why are we going for dou? Because this function f is a function of x as well as y. So that means what there are two level variables, and in the second level we have got two variables. That means what the differentiation with respect to f with respect to x or y would go as a partial. Then the second is dou f upon dou x is 0, dou f upon dou y is equals to 0, and solve these equations for x and y. Let a comma b the values of this a, x and y. Evaluate r, that is dou square f upon dou x square, s as dou square f upon dou x dou y, t as dou square f upon dou y squared for these values of a comma b. So after getting these values, or you can say a pair of equations from these two equations, that dou f upon dou x is 0, dou f upon dou y is equals to 0, we'll have to find out this r, s and t at these particular points. After taking those particular points, we have to take a decision whether any maxima or minima exist at these points, at this particular point a comma b. So if r into t minus s square is greater than 0, and first one, that is small a, is r is less than 0, then the f of x comma y has maximum value, and if it is greater than 0, then f of x comma y has a minimum value. After getting those values, we can say that okay, if r into t minus s, so this is the first condition, if it is greater than 0. So that if it is greater than 0, so maxa or minima will exist at these two points. But if it is less than 0, means what, f of x comma y has no extremum values at the point a comma b. So we are just talking about around this point a comma b, what is the scenario, whether the function has maxima or minima. If it is going to be greater than 0, then maxima minima exist. If it is less than 0, then neither of max or min will exist. And if RT minus S square is equals to 0, then the case is doubtful and need further investigation, which we are having. This is the you can say the limitation of this particular values which I'm working on. We are not going to consider the question based on this RT minus S square is equals to 0, because we need to go for some other investigations which we are not including in this particular section. And the points a comma b, which are the roots of dou f upon dou x is 0, dou f upon dou y is equals to 0, are known as stationary points. They are known as the stationary points. Let us discuss about one question, very small question. Discuss maximum and minimum of the function x square plus y square plus 6x equals to plus 12. That means we have to consider f of x comma y is x square plus y square plus 6x plus 12. Then dou f upon dou x is 2x minus 2x plus 6. That means we have to differentiate this particular function with respect to x. So we have only this two term. So x square differentiation 2x, 6x differentiation is 6. Similarly, we have to go ahead with dou square f upon dou x square, that is 2, because as soon as we are getting dou f upon dou x, immediately after taking the differentiation we are getting 2x. The differentiation of 2x with respect to x will give you 2. Similarly, dou f upon dou y is 2y. That means what? We have to differentiate this particular function again with respect. So what we have done, this f we are differentiated with respect to y. So we got 2y. Similarly, again we are differentiating this with respect to y again, which we got it as 2. That means dou square f upon dou x dou y means what? Suppose for example take this function dou f upon dou x. 2x is 2x plus 6. Differentiate this particular dou f upon dou x with respect to y now. So we do not have any y into it, so differentiation would give us 0. After that, for the condition of maxima minima, this dou f upon dou x is 0 and dou f upon dou y is equals to 0. That means what? We have to solve these two equations simultaneously. Which are the equations? Equate this with 0, equate this with 0. So we are going to get these equations. After getting this equation, we are getting x is equals to minus 3 and y is equals to 0. Means what? At minus 3 comma 0, we are having RT. So we have got this one pair for this particular values. So at this minus 3 comma 0, so this is nothing but the value of a comma b, we got it as here. So at this RT minus s square is giving you 2 into 2 minus 0, because if you observe here, R is nothing but this. So this is R, this is T and this is S. So RT minus S square is giving you the value as 4, which is greater than 0. Means what? We are getting, and similarly that means what? We do have maxima or minima at this point a comma b, but we have to take a decision whether it's min or max. So we can take that decision from the value of R. R is equals to 2, which is coming out to be greater than 0. Right? If it is greater than 0 means what? The function f of x comma y has a minimum when x is minus 3 and y is equals to 0. And what's the value of that? That means we have to put x as minus 3 here, y as 0 here. Take this point and just go ahead. So we'll be getting the value as plus 3, which is the minimum value of this particular function f at the point minus 3 comma 0. This is very simple type of questions as an applications of a partial differentiation. Okay, and this is a self-observation wherein 1-2 questions has been given along with the answers here. Thank you. Happy learning.